Okay, hello. We're gonna start in a bit now. All right, let me share the screen first. Okay, now, if you have the notes, you will probably notice, right? We are doing a few subtopic, few chapters. Now, we will not do the whole chapter because a bit. I figured that this is better because in a way, right? What I wanted to do is more towards your weak subtopic lah. You know, some chapter particularly you are very lousy at it. I mean, deep down inside, you know lah, right? So this is why, right? You can see the notes here. Okay, so what you have should look a bit something like this. Okay, so as you notice, I put in a few multiple short notes for you. A bit of reading material, when you can go through yourself, a bit of recap. If you have any problems, go through them, definitely, right? So now, how this thing works, see, what you have here, right? You can see number one, the typical problem you have about chapter 3. Okay, people always ask about this man-made satellite thing, and to be honest, is it important? Yes, very important. Why? When we say chapter 3 why are they more likely to come out essay? Which part of the chapter 3 they come more likely to show up in your exam, right? Is definitely this man-made satellite. I mean, for the coming exam, right? So what I did for you here, let me go through one round for this short notes here before I go into the questions. Behind, I prepared some of the questions for you as well, according to what I feel like is more important for your coming exam, for your midterm. Okay, so now here's the thing. You will see sometimes, right, I put question answer, I make it in the Q&A style because sometimes, right, everybody got this problem. They will tell me like, I study, right, I understand one, I read the notes, right, I understand one, but then the question come out, I cannot understand, I cannot answer. So what I did is I do like Q&A style, right? I'm telling you what they ask you in exam. I'm also telling you what you should answer. So it's like a notes, but it's actually catered and designed for you to answer your exam question as well. All right. So for example, this one here, very standard thing. Whenever you have a satellite orbiting the Earth, right? So what happened is that when we say satellite, usually we can just simply categorize them in two parts. You got the geostationary, you got non-geostationary. Okay, now a lot of people tend to ignore this. You will feel like, hey, non-geo not so important, right? To be very honest, when we say non-geostationary, it's a very wide range. For one reason, because, well, when we say non-geostationary, it means that whatever satellite is not on a geostationary orbit. So let's say this is geostationary. So now, if your satellite is further away, okay, further than geostationary, it's considered non-geo. If it's closer, it's considered non-geo. Yep. But normally we will use the nearer one actually. Now, and yes, we do have application for non-geostationary. So this is why, right, what I did was, you see, I tell you, number one, of course, the most famous one, the most important one is the properties of your geostationary. You know what you're going to use it right now? Where you're going to use it, right? You can see, I put in 1, 2, 3, 4, 5. You know why I give you 5 characters, 5 properties? Where do you think you're going to need this? Where do you think you're going to need this? 5 properties. Think about this. 5 property means what? They are going to give you 10 marks, right? So where do you expect this thing will come out in exam? This is normally they ask for essay one. They ask you, say, hey, design a satellite for me. I want my satellite to broadcast live, my football match, or let's say Olympic Games, whatsoever. Whenever we do broadcasting, right, there you go. Okay, we will be using geostationary satellite. Okay, so they're gonna ask you choose like, hey, I got 4 satellites. Which one is good? Which one is supposed to be the answer? Which one is supposed to be the choice of your most suitable satellite for broadcasting? So these will eventually become your answers. Now sometimes, right, they go a bit crazy. They go a bit not to say crazy lah. Geostation is more like a mainstream kind of question. Sometimes they might ask this. So do we use non-geo? Yes, sometimes, right? Then the question is, why do we use non-geostationary? So what I also mentioned here is your advantage. What's the good thing about geostationary? What's the good thing about non-geostationary? You answer according to needs. All right, both got usage one. Now, by now you're supposed to know. Physics is really like this. You will have, the good side of there's 2 sides of the coin. So we don't have absolute answers. I will not be able to tell you that, oh, geostationary is the best. The object density is supposed to be heaviest. the better. No, it will all depends on what you want it. Object heavier, is it good? Yes. The object lighter, is it good? Yes. Object bigger, is it good? Object smaller, is it good? Both also, it will all depends on what the question required. So that's why I give you both sides lah. You know, advantage of using geostationary, advantage of using non-geostationary. Getting the point, right? So that's the idea. Now, when we go back to this point here, right, regarding this man-made satellite, I give you a bit of formulas as well. Also, one thing they like to ask a lot, because you think about essay, not just only the essay part, you will ask you for explanations and everything, right? So this is when you get this, how or why your satellite orbit. Because now, normally they come out a question 4 marks first. As you explain, then only they go into the essay part. So explain part and then essay part. Okay, so this is where I prepare all this thing, go through with you lah. Now, of course, I will not go through every subtopic for chapter 3 lah. Of course, you say, hey, my chapter 3 very weak. Now, I need to choose whatever topic that I feel like is more important. So of course, you cannot expect like, oh, I got zero knowledge in chapter 3. Can you tell me the whole thing? Now, the problem is we simply don't have the time. Okay, so next, right, we got this interference of wave. In wave, right, you know, one thing that I noticed everybody kind of lousy at, kind of, you know, having problem, it's this subtopic here. Interference. When you got two waves intersecting each other, that's why I call interference. So again, let me go through roughly first, right? Again, what you have is the formulas for interference. Simple. Chapter wave, right? To be very honest, there's only 2 formulas. Okay, there's only 2 formulas in chapter wave. The wave speed formula and this one. Lambda equals to ax over d. So all this ax over d, when we go through question, I go detail. Then after that, now, for interference questions, I need you to know 3 things only. If you can do all 3, then you're good to go already, one. Because in exam, right, interference questions, they will separate into 3 types of questions. Number 1, right, you get this water wave interference. Okay, now then second thing, you will get sound wave interference. And then after that, you will get light wave interference. 3 types. Now, of course, every questions it will be different. Okay, every question it will be different. For example, if they ask about water wave, what do they ask you? Number 1, the name you get, the name you are using will be very specific. For example, when we do water wave, right, you will see a lot of all these anti-nodal lines, nodal lines kind of thing. Then of course they ask you lah, hey, what happened at anti-nodal line? What happened at nodal line? Okay, and then typical constructive interference. Remember, there's 2. A lot of people forgot about this, right? You tend to only think that, oh, all the crest and crest combined together, it's constructive. Now, anything same combined together is constructive, right? Now, let's say for transverse, you will have the crest and then the trough. So you got both the crest combined together, that's a constructive. You got both the trough combined together, that's a constructive as well. Now, destructive is cancelled. Cancel means what? You have to be completely opposite. Crest and trough combined together. But that one only applicable for transverse wave, because right, we also have another wave known as longitudinal. Sound wave is one and only one, the example for longitudinal. So when we come to longitudinal, right, we don't do them we don't call them crest and trough anymore. We will start using compressions and reflections, right? But again, what they will ask in exam, I put nicely for you one. Typical thing, the meaning of coherent source is what? And then, as I said, what happened for anti-nodal and nodal line, that kind of thing. We go details, relax, okay? Now, in interference, one thing very important is this. Sure ask one. Whatever. No, this is not meant for water wave only. Literally, every wave, as long as you are doing interference, they like to ask you one. What happened to X when lambda increase? What happened to X when A increase? What happened to this when what? Now, remember one thing, okay? The formula, yes, it looks scary because why? Lambda equals to AX over D. There's a lot of variables, right? But let me ask you a question. When you do an experiment, when you carry an experiment, right, how many responding variables you have? When you do any kind of experiments, how many responding variables do we normally have? How many? Hey, hello. Come on, man. I know you are still, you need to answer me so that, I know you're not asleep. Yep. And also, keep yourself active. here's the thing, responding variables. I'm not asking for variables only. So listen to my question very carefully, right? How many responding? 1. Okay, then after that you have like, manipulated, responding, and then constant, right? So that's why, remember, whenever you're doing experiment, 1 and only 1 responding. And when we say interference, the responding variables, it's always the x. Okay, because you say, hey, but the formula is lambda equals ax over dy, right? Why? Now, simple as this, because the rest of them, right, they are all manipulated. But again, when you do experiment, how many manipulated variables you have? You listen to my question carefully. When you do experiment, how many manipulated? 1. Yes. So of course the problem is what? Every time they ask for 1 variables, 1 manipulated, 1 responding. So you can see, right, these are 3 separated questions. You not gonna get a question asking you, hey, when my lambda increase, what happened to A, what happened to X, what happened to D? They won't. Or they won't say like, hey, when lambda increase, A increase, what happened to X, what happened to D? No, they don't. The reason very simple, because it's not possible. That's why, right, whenever we ask for a relationship, okay, okay, what happened is that now you look for this thing, and then the other one, let's say for example, first questions, they ask you what happened to lambda, then you make sure the rest of them is constant. Okay, what happened to what happened when D increase, then the rest you make sure they are constant. It's like doing experiment. Okay, 1 manipulated, 1 responding, the rest is all control. The rest is all fixed variables, constant variables. Getting the point, right? So these questions, always remember, whenever they ask for this happened, that happened, right? Remember, they only affects your x. X means what? The distance between your constructive or destructive interference. Like for example, a water wave means anti-nodal line distance, nodal line distance. But when we go to sound wave, no more anti-nodal, nodal. Now, right, sound wave, sound, what happened? They will combine, they will cancel. And logically, when the sound combine, what happened? They go louder. What happened when the sound cancel off? They become softer, right? So that's why, what happened for this, you see, when we come to sound, the name changed, become compression, compression, rarefaction, rarefaction. Because why? This is longitudinal. So these are all the frequent questions, and you trust me now, okay? You go through this, surely benefits whatever you need one. To be very honest, a lot of you say, I got study one. Okay, I got prepared for exam one. But you always got this one problem. You will feel a bit uneasy and you feel scared. Like you're not sure whether you finish study everything or not. So what I put inside here, right, it's essential. It's where people normally make mistake, what the question usually like to ask, and where students always get stuck and you get tricked in exam. So of course, there will be question behind, but you understand now, we are not making the whole book for you, right? That's called reference book. What we have here is essential, where you normally get tricked, basic concepts, common mistake that you normally do. So frequently asked questions about sound wave interference, then frequently asked questions about light wave interference. So all these things, right? Okay, I prepare nicely for you. I go through this with you. Okay, Now finally, of course, we got this one here, one of the problems that everybody will ask me, hey, my chapter like very bad, my chapter like, feel very lousy, then how? The formula is very difficult, sometimes plus, sometimes minus, how? That's why here I also talk about lens, right? You can see the formula, the drawings, and also compound lenses that people get stuck with. So I give you all these short notes so that you can prepare nicely, and also a bit of Form 5, the equilibrium of forces, how you calculate them. I put them in a very detailed ways so that you know what happened or not. When you go through it yourself, you read through yourself, right? You also understand what's happening on. So as you can see, we go through, all this is what you need for details. You get it? So we go questions. I will explain about the theory first, and then we go questions, explain our theory first, then we go questions. Now, first thing, of course, the one big problem that we need to definitely clear out today, it's this subtopic first. Okay, I'm not going to go by sequence like that. We go through all one by one. Okay, So first of all, we got lens. Okay, first of all, we got lens. What do you think about your lens? What do you think about your chapter light? People always get problem with this, especially for a midterm. Why is that so? Because light, right? You learn this at the year end. Your finals never really test too much. Then you don't really put too much of focus and attention to it. Then the midterm exam, they start spamming light questions. Then you are gone. Now, of course, in chapter light, we got more than this, you know. You got lens, you got mirror, and then you have the typical refractions, total internal. So I chose the one that people always, you know, get stuck it. You always will ask me, hey, my lens how, right? So let me tell you one thing. In chapter light, how does it work? In chapter light, the entire chapter light, right? You can separate the topic into this way. The whole chapter light, right? You can separate them into two parts. They basically require two skills only. Number one, it's the drawing side. Number two is the calculation side. You think about your light, they revolve around these two things, right or not? Drawing is one thing, calculation is one thing, right? Drawing is one thing, calculation is one thing. So when we say drawing, we got typical two types of drawings: the normal drawing and the specific technical drawing. Normal drawing meaning what? Like the standard one now, when you're drawing for refractions, they ask you whether bend away, bend towards that one. Total internal reflections, whether you should bend 90 degrees or whether should you reflect the same angle. Those are the normal drawing. Not too much of technical skills. You don't have to refer to a specific point, so you just draw agak-agak. But then later on, you got all the technical drawings, like what we know as the ray diagram. What you have, the lens, the mirror, and also the compound lenses. Get it? Now, the lens wise, let me tell you what. Okay, a lot of people get stuck with. But to be honest, I give you a simple trick. You settle for all. Okay. Now, how many types of lens you have? How many types of lens you have? Two, right? You go convex and then you go concave, right? Okay. But first of all, right, I want you to understand this word first. Okay, because when we come to lens and then you do mirror, you get confused one. Because you feel like, hey, why in lens, right, I got convex lens. And then when I come to mirror, I got convex mirror. But the drawing is very different one. Exactly. So normally, right, I recommend students don't separate your lens and mirror into convex and concave group. Like that, you sure confuse one. Because convex lens on convex mirror, it's different. Concave lens and concave mirror is different. You get me, right? Because lens light go through. Listen to this, lens light go through, mirror reflects light. So instead, what I want to teach you today, whatever you find useful, kindly write down. If you tak sempat to copy, you know, I will give it about a few more seconds for you. Take a screenshot. Then forever you can slowly to draw, to write down whatever lah. Okay. Now, so normally, right, whenever we go through when I go through chapter light, I like to learn lens and mirror together, because I will see the similarity between them. I will see the common thing, the differences between them. Now, idea of learning. How do you go faster? How do you learn faster? The key to learn faster, study faster is what? Shorten your time. Okay. Normally, suggest two things. Number one, look for similarities. What is the same between things? Because why? When you do that, you study one time, you can remember the rest because they're same anyway. Second, look for differences, because when you study one, reverse the logic, it becomes different. So when you do that, you shorten your time. Okay, let's just say we do differences. You shorten the time by literally 2 times. Because why? You don't have to study 2 sides. One side, the balik answers. All right. Then on the other hand, similarity even better. If you got like 5%, same thing one actually, the same properties one, you study 1 time, 5th. You get me, right? That's the idea. So now, instead, what I recommend you to do look, normally I will recommend students to remember these 2 words for me. Okay. Number one, we got something called converging group. Okay. Then second, we got something called diverging group. Have you seen these 2 words before actually? Have you seen these 2 words before? Regarding this converging and the diverging. Have you seen it before? Converging, diverging? Yes, there's no yes. Okay, simple as this. Question number 1. Do you know what is the meaning of converging? Converge means what? You don't care what we talking about, lens or mirror. Converge means what? Converged. Converge means focus. Exactly. Converge means focus. Converge means combine. Okay. Do you notice some lens, they focuses light? Right. For example, what kind of lens, right? You put it under the sun, right? It will focus the light to one spot on. You know, when you were a kid, you like to put it under the sun, then you try to burn some leaves or paper and stuff like that. What do? Magnifying glass. Exactly. Then you start thinking again, Magnifying glass is what shape? Magnifying glass, does it comes out or go in? It comes out, it's convex. It goes in, it's concave. What do you think it is? Exactly, it's a convex lens. Okay, now that's why what I recommend you do, you see, under converging, we got 2%. Okay, you have the converging. Under converging, we got 2%. One, you actually have the converging lens. Then you have the converging mirror. Okay, 2%, converging lens, converging mirror. Under diverging, you also have diverging lens, and then you have diverging mirror. Well, you know what? People always will say like, hey, like that also need to memorize, right? No need. Why? I just need to remember one, which I told you already lah. What kind of lens? You put it under the sun. They focus the light one. You tell me magnifying glass. Magnifying glass means what? It will be under convex. Make sense? It will be under convex. Correct. Now, once you can remember this, everything easy. Why do I say so? Now, lens and mirror, right? They always terbalik one, reversed. So, if I say convex lens is converging, what kind of mirror? Terbalik. Reverse of convex is what? Reverse of convex, it will be concave mirror. Good. Now, what about the other side? Again, since you already said this is convex lens, what do you think about diverging lens? What kind of lens, right? You go through, then it opens up one. The other one, yes. Then what you have? Then you got concave. Then yes, then you have concave lens. And again, I say what? Mirror, terbalik, concave lens. It will become convex mirror. There you go. Everything comes out already. Notice that? Now, which one has the most applications? This, and this. Okay, now first of all, convex lens, it's magnifying glass. To be honest, most of the application for lenses, right, we will use convex. Your projectors, your telescope, your microscope, all those are convex lens, right? Concave mirror got a bit of usage, but then normally the one you see out there, it's convex mirror. You know what usage for this convex mirror? Smart guess, convex mirror. You know the 7-Eleven one? They put it on the corner. The mirror come out or go inside one. Comes out, right? Convex, okay? And now, people, if you're going to confuse about this, let me tell you what. You remember this? Cave means what? Cave, it's like a hole, right? Like the cave in the jungle and stuff like that. So whenever you notice it curves in, it looks like a cave entrance, right? That's why we say concave. So you can remember cave, then the other side settle. Now, yes, also people will say the T-junction. Yes, convex mirror got a lot of usage one. Okay, people use it for blind spot mirror. People use it for the corner one, the security mirror. And sometimes we also use it for rear view mirror. You know, car, the mirror to look at the back. Yep. Now for car got two. Sometimes you have plane mirror. Sometimes you will have a concave mirror. Oh, sorry, convex mirror. Okay, so they are different. And of course, you see, then you will probably ask, hey, how do I know whether my father's car, right, is it a plane mirror or is it a concave mirror? Okay, now, concave, convex mirror. Now, a lot of people will ask about this, but let me tell you one thing. You know how you differentiate or not? If your car is using a convex mirror, there will be a line of wood there on. Have you seen that before? Normally they will put like, you know, something like this. Let me show you. Can you see this now? You go and look at father's car later. If the mirror there put this object in mirror are closer than it appears, that means convex mirror. Okay, another one example here. This one, object in mirror is closer than they see. See that? Exactly, your exam. Now back to this. So that's why, right? What happened for this? Concave, convex mirror. There we go. Right? Now, after you categorize this, why do I like to do it this way? Because as I said, remember I say, right, what's the way of studying faster? Looking for similarities, looking for common things, looking for differences as well. First of all, under converging, we got two different groups. Under converging, we got two guys. We got convex lens, we got concave mirror. Under diverging, we got two person, concave lens, convex mirror. There's no need to memorize them because why? I just need you to remember one corner, which I said already. The best way to start, it's actually these are right. What kind of lens focuses alike? Convex. And then every time you flip, okay, convex lens, when it comes to mirror, flip become concave. Concave mirror, flip become convex mirror, then flip become concave lens. So you just need to remember this, notice that. Then you flip, everything comes up. And now, why do I like to do this always? Let me tell you what. Number one, when you do this converging, diverging, when you do these separations, you will notice one thing. Okay, first of all, the drawing is very similar. Converging, diverging, drawing, very similar one. Okay, not exactly same, of course. Later I'll show you. All right. Second, the characteristics of the image you get is the same. As long as you put the object at the same locations, as long as you are under converging, right? I don't care is it a converging lens or converging mirror, you get the same image. Diverging, on the other hand, same. As long as you're having a diverging lens or diverging mirror, you will get the same image characteristics. So you see, I memorized one time, I'm actually memorizing for both the lens and mirror. I memorized diverging one time, I'm memorizing for both the lens and mirror. See that? So this is how you study faster and waste lesser time doing though. Right? Now, make it simple to you lah. Okay, I give you an example. Why do I say so? A lot of people say, God man, right? Okay, how about this? Hey, why my name different? Gone already one. Oh, sorry. You. How lah? How? How lah? How? Okay, sorry, I need to type this again. Converging, and then we have diverging. Okay, now guys, number one, speaking of the characteristics, do you remember them? Remember when we say characteristics, what kind of characteristics we have? They usually like to ask about those, real, virtual kind of thing. Then after that, you have magnified, diminished, inverted, upright. Do you recall this thing? Okay, first of all, every time when we describe characteristics, right? Three things. The size, how? Three answers only. Either you get bigger, magnified, smaller, diminished, same size. Three answers. Magnified, diminished, same size. Second, you will talk about the orientations. Same directions, upright. Opposite, the terbalik, one go up, one go down, inverted. And then third point, right? It's gonna be what we know as the nature of it lah. Okay, it's basically the real and virtual thing. Yep. Let me show you a simple way of memorizing them. First of all, we talk about this guy first. Converging. See, again, what I'm teaching you now, it's a shortcut for all. I don't need you to memorize for both. As long as you are converging. I don't care lens. I don't care mirror. As long as converging. Okay? Use this. Okay. So how do we do this? Look. So normally, right, what you have is something like this, right? You will get the lens in the middle of here. Okay, now again, here could be lens, could be a mirror. Don't care, as long as they are under converging. But anyway, since we are getting use of it, am I right? Can you tell me what are we doing here? I mean, sorry, we are having converging here, right? Come, converging, under converging group, what do we have? Under converging group, who do we have? Two person, just now we say already, right? Who's that two converging person? Always remember first one, which is, yes, convex lens. Okay, lens, some more. Mirror, what you do? Terbalik. Convex lens means become concave mirror. Okay, so that means, listen to this. Now, the shortcut for this, right? Applicable for both. Convex lens also can use, concave mirror also can use, right? Meaning it can be either like this, convex lens, or either like this, concave mirror. Both also applicable. Now, first of all, remember when we go through all the drawings thing, right? Always you got all the point they mark down for you. Well, no matter lens or mirror, it's always the same, right? You always get two particular point, right? You always get two particular point, right? What do you call this point? What do you call this point? Whether lens, whether mirror, same. There's always a one point in front of the mirror, in front of the lens. What do you call that? You know the letter F, focal, where I got focus? Focal point. Exactly. Focus point. The one is you're not focusing in class already. Focal point. What about this guy here? The next one is, okay, this one will be different a bit. If it's a lens, listen, if it's lens, right, it will be 2F. Okay, F and 2F. And of course, you know what means by 2F, right? Literally maths, F to F. Meaning that if you say the distance here, it's 5 cm, then the distance here, 10 cm, 2F, twice of F. Well, if you do mirror, it won't be 2F anymore. Okay, if you do mirror, it will become, what is it? If you do mirror, it's going to be C, center of curvature. But actually, right, it's the same thing one. C and 2F is the same thing. Also, twice of focal length. If your focal length is 5 cm, your 2F, your center of curvature, 10 cm. Understood? Okay, so this whole idea, I need you to remember 2 points only. As long as you got these 2 points, every characteristic settle. Now, first of all, we talk about this one here. Okay, we look at this every single time. How? Simple. Look, number one, whenever you have 2F, you have C, right? We use this point to determine the size of the image. We use this point to determine the size of your image. As in how? Now, first point here, if, listen to this, if the object is located exactly on focal point. Okay, exactly on focal point, exactly on 2F or C, as in here, okay, exactly, and like literally if your object is like this, if you put an object here, when you put it object exactly here, right, what happened, your image will become same size. Okay, your image, for sure, confirm, same size one if you put here, meaning that your object how big, your image also how big. Getting the point now? Then next thing what happen is, if your object is located anywhere here, okay, if your object is located anywhere here, lesser than 2F, lesser than C, then your image will definitely become magnified. The closer to the mirror, the closer to the lens, your object gets big. Sorry, your image will turn out bigger. A simple experiment. Now you see, this is my lens of my camera, right? The lens of my camera is a convex lens, of course, right? You look at my face now. You know the face cam. Do I look big or small to you? Do I look big or small to you? Because object far away, right? Now, if I come closer, what happens now? Do I look big or small to you? Why? Because object closer, the image form bigger. So when we go closer to the lens, the image is bigger. When we go further away from the lens, the image is smaller. Getting the simple idea? There you go. Now, on the other hand, of course, one more thing we have, it's actually over here. Now, anywhere, when we have object, anywhere, whenever we got, perhaps different color, okay, whenever object located here, okay, anywhere after more than 2F, more than C. What did I say? If the object further, what do you expect to see? I mean, you got answer already, what? Isn't it? You expect answer already, what? Isn't it? Was it? Yes, they become smaller. Smaller means what? Smaller means you will get something called diminished. So you see, now you get all the size ready, right? Diminished. All the size settle. Okay, you see? Put here, exactly same size, closer, magnified, further, diminished, settle. Okay, size settle. What we do next? Then we go to after that, right? Next thing we go to, it's actually the focal point. Now, if your object located on focal point, what is this point for? Well, focal point, it's for you to determine whether your image is real or virtual. Okay, now, if your object located exactly on focal point or anywhere before focal point, literally, from here to here, okay, on focal point or anywhere less than focal point, then your image will definitely be virtual. okay, your image will definitely be virtual. And then back to this, if your object located anywhere more than F, as long as they are more or further away from F, right, then your image will turns out to be real. If you put it here, then your image will definitely be real. Now, of course, you say, hey, we are running out of points, but we got one more thing to decide, right? The orientations. Okay, this is when you look. If your image is virtual, then it will be upright. The orientation will be upright for sure. Now, this one comes in a package one. Virtual, upright together, regardless, whatever lens, whatever mirror, they comes together. Real, right? It always comes together with this inverted. Okay, real image, inverted, comes together as one package one. So virtual, upright, one package, real and inverted, one packaged. And now you get every single characteristics for converging already. Okay? So what you simply have to remember is we use 2F to determine the size. On 2F, same size, closer, magnified, further diminished, settle. Now, we use focal point to determine whether is it real or virtual. On focal point, less than that, virtual. Anything further away from focal point, that's real. Virtual and upright, always one package. Real and inverted, one packaged. There you go. Every answers. Okay? Questions so far? Okay. You stop first. I know you're copying, but you stop and listen to me first. How to use this thing. Later I give you some time to copy, but pay attention. If I put object here, okay, what kind of image I get? If this is my object, then you see, I basically in this region, right, what kind of image do I get? It will be real, inverted, diminished. See that? Real, inverted, diminished, settle. Now, if I put the object over here, what kind of answer do I get? What kind of image do I get? I get real, inverted, and magnified. There you go. If I put it here, what kind of image do I get then? Virtual, upright, magnified. Answer for all right. Come. If you find this useful, kindly write this down. Let me know when you're done. Diverging later. One by one. You do this one first. Meanwhile, I show you the diverging. Okay. You write down first, then I talk about diverging later. Okay. Are you done? Are you done? Okay. So after this, we talk about the diverging. Who do we have? Who do we have for diverging group? Same thing, all right. Under converging group, convex lens, concave mirror. Who's the diverging group? What do we have on diverging group? Come. Diverging guy. What's that? Concave lens, correct. One more. Convex mirror, correct. Okay. Now, diverging, even more simple. Exam come out diverging. Yeah, that day is a good day lah. You know why? Diverging, right? You don't need to go through all this, the diagram whatsoever. No need. Why? Let me tell you what. Diverging lens, diverging mirror, they only have one answers. Meaning regardless where you put the object, doesn't matter where you put the object, right? The image you get will be the same. As in what? Number one, okay. Oh yeah, I think this one needs to go smaller. Number one, the image will definitely be diminished. Number two, the image will definitely be virtual. Number three, the image will definitely be upright. Okay, so there you go. This is your one and only one answers. Write down and then we can move on. Yes, that simple. Yes, that's why in the exam, right? They don't like to ask this because too simple already. And there you go. See, converging, shortcut, diverging, one and only one answers. Diverging image. That's why you see, when you know this, life simple, right? You don't have to go through everything, Diverging lens, diverging mirror, everything. Diminish, virtual, upright. They don't change one. Diminish, virtual, upright. Always smaller, always virtual, always upright. Simple as this. Any questions over? Are we good? Can I move on now? This one quite easy lah. You just write down quickly lah, okay? Later I help you. Later when we're doing questions, you can tell how do we apply them. All right. I need to move on already. Okay. Quick. 5 seconds. If it doesn't part, screenshots are okay. 5, 4, 3, 2, 1. Next. All right. Drawings. Another problem for people always got this problem with drawings, right? Let me tell you what. Lens drawing actually very easy one because why? I teach you one method for both lenses. Convex lens, one method. Concave lens, one method. No matter where the object you put, same way of drawing. No matter where the object you put, same way of drawing. Okay. Now, first of all, you tell me first. Convex lens under converging or diverging? Convex lens under converging or diverging? We need to pick up the speed already. So I start slow because I know slowly picking up. Now you probably woke up already, right? So I want more response. I want a faster response. Okay. So convex lens under converging, good. Concave lens, it will be under diverging. Okay. Now, every time when you're doing convex lens, two lines only. Every time. Now, of course, if you look into your book, right, they will teach you 3 lines. But whenever we draw lens, we draw mirror, we want to form image, you need intersection. How many lines do you need for intersections? 2 only, right? You don't have to draw 3 one. So 2 is enough already one. That's why. So first one, right? Always what you do. Step 1, you do this. You go straight. Okay, means you draw a straight line. Okay, and what means by converging actually? Converge means focused. That's why when we go straight, after that, where we go? We go to focal point. We go to F. Now, second line, what you do? Go through the center of the lens. Now, let me tell you what. This is a very, very, very useful line because why? All the lens does this. Because when light ray go through center of the lens, right, there won't be any bending at all. Light go through center of lens, there's no bending. That's why we just go right through straight line settle. So every time, right, when we drawing convex lens, you draw 2 of these lines, answer will come up. Go straight, go to F, go through the center line. Quickly, we go through this. Look at this. All right. Now, for example, this one object they put in front of F. Oh, by the way, shortcut. Can you tell me what image do I get? Without even drawing it. I show you the shortcut already. Right? Now see, the object is here. It's before 2F. And definitely if it's before 2F, it will definitely be before F. It means it will definitely be before 2F. Right? Now, first of all, magnified and then virtual must be upright. There you go. Right now. Look, if you put here, if your object is here, right? You see or not? Your object is over here. What image do I get? Virtual upright magnified. This is the shortcut usage. Get it? Okay, never mind. We draw and see. Okay. Now, when we draw this, how are we going to do? First line, how to draw. From the object, always start from the tip. Go straight, go straight, go straight. One rule, remember, when you drawing lines, right, don't stop here. Go inside. Whether is it lens, whether is it mirror, right? Always go into the straight line. Don't stop at the curve. Go inside. Next thing, where do we go? Use the method I teach you. Go straight, go to F. So go straight, where you go? Go to F. Settle, right? Second line, what you draw? Go through the center of lens, right? Here, you aim to center of lens, as in this part here. So straight through. Now, if you look at this line, right, what does it look like to you? You look at these two lines. Do they look like they are intersecting? Yes, they are getting further away from each other. Then how? No lah, it's not parallel. They look like parallel, but it's not. Okay, now, whether is it parallel or not, very simple one. Whenever you feel like you're not going to intersect here, what do? Extend on the other side. Extend on the other side. So, if it's parallel, when you extend, you can show they are parallel. They won't meet. So, whether is it parallel or not, right? Anyhow, you must extend one. You extend to show your teacher, are you going to get any intersections? Are you going to get intersection? In this case, yes. But one rule is very important, remember, any line that you extend yourself, they must be dotted. Okay, lines that you extend yourself should be dotted. Because by right, you know what happened or not? The lines, right, it's over here, straight to focal point. This is your actual lines. All right, these are your extended one, right? So don't forget, draw the arrow. Arrow is basically what I said. Go straight, go to F, go through the center, right? And then look, intersection here, right? This is where your image will form. And remember, your intersections, if it's a dotted line, you get a dotted image. If it's a solid line, you get a solid image. So over here, all the way down, you are going to get a dotted arrow. Get it? In ray diagrams, what does it mean when we get a dotted arrows? What does it mean when we get a dotted arrows? Dotted meaning that they are virtual. Getting what I mean, right? And look at the size, please. What do you think the image compared to the object? Bigger, smaller? Magnified, correct. And then look at the orientations, both pointing up, meaning that, okay, listen to this. I want to tell you one thing. People confuse. When we say upright, what's the meaning of upright? Does not mean the object is pointing up. The image is pointing up. No. The object and image, same orientations, same directions. So if both objects point downwards, now like this is called upright also. Upright, upright. Inverted, inverted. You get it? So upright, a lot of people get cheated by the word up. No, does not mean pointing up. It means same orientations. That's why, right? Virtual, upright, magnified. That is exactly what you tell me just now. Am I right? Your drawing shows your shortcut works. All good. Now, never mind. We try again. I say already now, one method for all. Object. How? The bottom diagram. From here, go straight. And then where do you go? Go to focal point. Second line. Where do we draw? Second line. Where do we draw? Go through the center. Now, this one, yes, you are going to get intersections, right or not? Sorry, I need to cheating a bit now because they went out already. And look at the lines. The intersection, was it a solid line or was it a dotted line? Was it a solid line or was it a dotted line? Solid means what? Solid line gives you solid image like this. Get it? What kind of image do we get? Okay, never mind. Shortcut again. Where are you? The object is here, right? Okay, first of all, you notice, right? They are located before 2F. This will tell you it's magnified. Second, they are located after focal point. This will tell you they are real and inverted. Settle. And then look at the drawing you did. Is it correct or not? Is it magnified? Is it real? How to tell it's real? Solid means real. Dotted means virtual. And then real and inverted, one packaged. Any questions regarding this drawing? See, shortcut for drawings. Do these every time they ask for a convex lens. Okay, use this shortcut when they ask for characteristics. So far so good. Actually, you don't have to draw lah. The answer I draw for you already one. I've show you the process only. Because a lot of times when you look at the answers, you can't tell. Because you didn't see the whole forming process. So I show one time. Okay? I move on now. No, there's no need to draw for yourself because the drawing over. Of course, my drawing and this drawing are a bit different. It's very normal because this thing is not really up to scale. Next, concave lens. How? Also, one method to settle all. You know how you draw? Diverging. Okay, first thing also, you go straight. Every time go start from having a straight line. But now, right, what is the meaning of diverging? Smart guess. What means by diverged? Converge means focused. Diverge means, I mean, you learn in chemistry also. What means by the word die? Die means two. All right, separate. Okay, converge means focus. Diverge means separate. So, do I still go to F? No, right? So if it's converging, you go to F. Diverging how? You go away from F. Get it? Second line. I say already, ma. Whatever lens, there's one point you can always use. Go through center of the lens. Because light go through lens, no matter what lens it is, they will just go right through, no bending whatsoever. But let me ask you a question. Do I need to actually draw to find out to figure out the image? What kind of image am I supposed to get? What kind of image am I supposed to get? Diminished, virtual, upright, won't change. Now, I prove it to you. Let me prove it to you. Okay, first line, how to draw? Go straight, right? So from the object, I go straight. Remember, go straight into the middle line. And then go away from F. How do you go away from F? Remember, this is lens. Your light are supposed to go through. So how do you go away? Of course, this is not go away, man. This is go towards my right. But mind you, there's actually two focal point one. So that's why what you do now, look, you aim at this focal point. Okay, then you draw one straight line like this. But remember this thing, you're supposed to erase off this part. Because actually what happened? These are the reference line. Your light ray actually did this from here and then do this. So you want to show a teacher, where are you going? You are going away based on the focal point. This is the meaning of go straight and then go away from F. Understand? Second line, how to draw? Same, right? Object through the center, straight away. So arrow, go straight, go away from F, go through the center. Where do I get intersections? Over here, right? Now, as I said, whenever you get dotted lines, 1 also, 2 also, your image will be dotted. 2 lines dotted, dotted. 1 line also, as long as dotted, then dotted already. And of course, you can see you get a very tiny little small arrow there, right? Is it diminished? Dotted means virtual, virtual is upright. And there you go, shortcut works as well. Okay. All right, questions regarding this drawing so far? We all good? Everybody? Can I go on? I hope this brings back your memory. We need to maximize your revisions and, you know, recap all the things that you've forgotten. Now perhaps you have this kind of eureka moment. Oh, I remember this. Yes, it's good that you remember this. Can I move on? No need draw. You know what? I just need you to write down this only. Yes, the drawing I show already, man. Okay. All good, everybody. Hello. Dotted line is the line you extend yourself. Dotted line means virtual. Solid line means real image. Correct. If you get dotted arrows, that's a virtual image. If you get solid arrows, that's a real image. Yes. Okay. All right. Next one. Calculation wise, I need to remind a bit also because why? Now, final one part is what? You see, your formulas, to be honest, please remember. And now, formula sheet given or not, that one I say 1,000 times already. They give it to you or not, you somehow need to know yourself. You somehow need to memorize yourself. Because, yes, SPM got give. Your midterm most likely got give also. But do you think you surely get this? I mean, they're not going to put all formulas inside, you know. So, yes, need to know yourself. For lens, 3 formulas, most typical one. And especially this one, first one. You know, the first one that everybody gets stuck with, the lens formula. Now, you're not stuck with it. Most of the time, okay one, because I suppose you know what does the FUV stand for, right? What does the F stand for? Now, capital F, it's focal point. Notice I put a capital F here. Uppercase, focal point. But if you get a lowercase f, that's focal length, right? Whatever you measure, FUV, from the center of the lens, from the center of the mirror. Okay, now what does U stand for? Object imaged. All right, and then what does V stands for? Imaged. Sorry, my bad. U stands for object distance. V stands for image distance. Got it? Now P stands for power. You know, power of the lens, heard that before? Every time, you know, when you get a new spectacle whatsoever, your friend always like to ask you, what's the power of your spectacles? That's the thing, because your spectacle is a lens. How do we calculate power normally? We do 1 over f. The f stands for focal length also. But I got one reminder here, people always die on. Power you want to calculate, right? You have to make sure this must be meter. Okay? This one very important, because every time I see people making mistake. Now, I can tell you for now already, okay, 99.999%. The question they give you everything in cm. This one here, you put cm, not a problem. But this one here must convert. Okay, must convert to meter. Here you put cm. That one I don't care. This one also, you put cm. I don't care. Only for this one, you must put meter. SI unit. Understand? Now, one more thing, when we calculating for magnifications, right? Now, listen to this. Do you notice you got all the plus minus here? Later I explain further, right? But then whenever we calculating for magnifications, right, no need to put any plus minus one. It's just a ratio. What's the meaning of magnifications? They want to know that your image and your object, what's the size difference? Are they like bigger? Are they like smaller? Okay. Now back to this. So over here, you revolve around 3 things only, U, V, and F, right or not? The U stands for object distance, V is image distance, and then F is focal length. Okay, object distance, image distance, focal length. Now, why people get confused? Because sometimes, right? Okay, sometimes, right? They are positive. Sometimes they are negative. This is where people stuck, right? Let me tell you what. We go through one by one. Number one, I don't care what lens you are using, whether is it converging or diverging. Object, very easy one. Because why? Object is always real. There's no fake object. There's no virtual object one. That's why, right? No matter you are having convex lens or concave lens, right? The U, simple. Whatever number they give, use only. No need any positive, negative one. Now, moving on next. The idea for V. Okay, V is image, right? How many types of image do you have? How many types of image do we have? Okay, we don't care whether is it a converging or diverging, right or not? What happened? Surely got 2, the real and the virtual, right? Nah, follow this. If your image is real, okay, if your image is real, then you put positive. If it's virtual, then you put negative. Actually, same for concave lens. But you know why I put a negative here? I said already, right? Whenever we come out diverging lens, do you need to go through all the drawings whatsoever to find out the characteristics? No need, because why? Diverging, they are always virtual. So the V value always negative. Listen to this. They don't tell you. You have to know for yourself. That's a problem. You get it? Now finally, if it's a convex lens, focal length we put positive. If it's a concave lens, the focal length we put negative. So this plus minus thing, right, is where people forget every time. So this is actually important. Okay, they will always just give number. They're not gonna say, oh, the U is positive, the V is negative. No, they don't. They're just gonna tell you focal length 10 cm. You need to decide yourself. Is it a positive 10 or is it a negative 10? Understand? So that's the simple trick over here. All good. Now back to the magnification thing. You see, just now we mentioned, right, V and U, sometimes positive, sometimes negative, right? But when you substitute over here, no need. Just the number. No need plus minus. You just want to compare them. Yes, you are basically calculating the ratio of your size. Is it bigger? Is it smaller? But listen to this. For magnifications, right, there's only 2 things can put inside. Number 1, the imaged. distance, the object distance. Number 2, the height of image, the height of object. You see both the logic, right? Actually, these two. The idea is you're using imaged divided by object. But beside these two, cannot do others. Like for example, can I use volume over volume? Cannot. Can I use area over area? Cannot. Must be height or must be distance. Get it? And you know how you actually tell the image, is it bigger or smaller? By just looking at the number. Right, so very easy. You see, you take image over object, you take image divide object, right or not? Okay, let me give you a simple question. If the answer turns out I get 1, what does it mean by this? What's the meaning of this? When I calculate, I get m equals to 1. You think about it, your maths lah. Under what situation I get 1? Under what situation I get 1? When I get the same number and divide, right? What means by same number? Your height of image and object, same. Your image distance and object distance, same. Yes. That means same size. Okay, what if I get magnifications more than 1? What does it mean by that? What if I get magnifications more than 1? What is the meaning of that then? You know how you know how you get more than 1, right? It's basically when you get a bigger number divided by a smaller number. So on top is image, image bigger. That means what? Image bigger. That means what? You get a magnified image. So a lot of times based on this information, you can tell as well. Now next one also, what happened if I get less than 1? Less than 1 means, yes, simple as this. The image will be diminished. So sometimes without even looking at the drawings, the number also tell you answers. Okay, if m less than 1, diminished, equal 1, same size, more than 1, magnified. Right? If the value for v is more than u, you get this, magnified. V equals to u, same size. V less than u, diminished. That's why the more than 1, less than 1 equals to 1. All good? Clear? Now these are all the essential for lens. Okay, characteristics, how to remember, formulas, the trick, and then the common mistake you all do. Drawing for lenses, I already mentioned the methods. That means you are good for all questions already. Now let's try. Try to apply. Can I have you to turn to page number 9? This one, page number 9. Come, we go through together. Diagram 9.1, sorry, 5.1, 5.2 shows how a parallel light rays passes through 2 different lenses. F is the focal point of the lens. Look at this. That's exactly what we said just now, right? By looking at the diagram, could you tell? What is happening here? What is happening here? The light focus, right? Or the light focus to focal point, right or not? What's that called? I mean, what lens do you think this is? What lens do you think this is? No. Okay, convex lens, correct lah. But I also want the full answers lah. Okay, what kind of lens is it? I mean, what group? This one under what group? Yes, converging, because they focus. See that? Now, what kind of lens is this? This one you get convolute. This one you get diverging. And you notice what happened, right? Your light ray separates. That's why I say converge means what? Focus. Diverge means what? They are separating. So what kind of lens do we have here? Concave. What kind of lens do we have? Up here, convex. Are we good? Now this easy question, I go faster. If you have any problem, kindly ask, okay? Next one. Now, based on 5.1, 5.2, compare the type of lenses used. Now, this is the question I wanted to do, you know why not? Normally, how you do compare questions? Okay, my question is, normally how do we compare questions? Think about it. How to compare? How to compare? You normally do like, more than, less than, higher, lower. Remember that? Like in your paper too, right or not? More than that, less than that. Diagram 5.1 is faster than, right? But here's the problem. How are you going to compare this? Okay, how you more than, less than? The problem is how you more than, less than? You get it or not? Like, you say what? This one converge more than this. This one diverge more than this. Okay, now here's the thing. Listen. Actually, right, whenever we do comparing questions, every time when we do comparing questions, right, you got 3 answers. 4 answers. More than, less than, equal. That's the typical you get, right? More than, higher than, less than, lower than, and then equal, right? Now the fourth situation is this. Whenever you get a questions that totally no relationship one, you cannot compare one, then how? You just state the answer. Now, actually, the skill involved in your comparing questions. Okay, actually, we all got to go through all these skill things. One now, the skill involved in comparing questions. Okay, it's called observations. That's why I always tell students, right, you don't have to whenever go through compare questions, right, you don't have to use brain one, literally use your eyeball only. Yes. So actually, what means by comparing? Comparing means observations. So if you come across a situation like this, you cannot compare. What you do? Simple. Just tell them, okay, the answer. Straight away mention what? You tell them the type of lens used in the diagram. The type of lens used in diagram 5.1 is what lens? Convex lens. And the type of lens used in diagram 5.2 is concave lens. That's it. End of story. So this is why I wanted to talk about this, because normally, to be honest, compare question I don't discuss one. Waste of time. You can just compare yourself, right? But if you come across situation like that, you cannot compare one. Then how? Then state the observations. Do you understand? Same thing as well, right? Compare the parallel rays of the light propagates after the lenses. How do you compare them? I mean, again, tell what you see. What happened to the light after they go through this lens? What happened here? It converged, right? Okay, good. What happened to the lens? What happened to the light ray after they go through this lens? It separates and diverges, right? Yes, that's the answer. So what do we say here? Okay, the parallel rays in diagram 5.1 converged to focal point after pass through the lens. The parallel rays in diagram 5.2 diverge away from focal point after pass through the lens. Okay? I give you 2 sample questions only. The bottom question I leave to you already. Because anyhow you get answers also. I talk about the answer later. Okay? So get the point? Get it? So the rest of the question I leave it to you. Anyhow, same way of doing. Whenever you cannot compare, do this. State the observations. We good? Okay. So sometimes, to be honest, question like that is rare, but it happens. So every time this one comes out, right, everybody die one. Because you were stuck there and say, hey, how to compare? Cannot compare, then write the obvious. I mean, not write the obvious, write your observations. That's my point. Okay. Can I continue more? Can I continue more? We good? Next one. Okay, this one I leave it to you. Next one. Now over here, diagram 5.3 shows a movie showing at GSB Cinema. Based on diagram 5.1, 5.2, which lens suitable to be used as a projector? What kind of lens we use for projectors? Okay, here's the thing. Your answer, your keyword is this word actually. You know what is the hidden meaning behind this thing? If you're going to use it for projector means what? The image must be able to be projected. No, magnify is not problems. Okay, when you want to be used in projector means what? Your image must be able to project it. Yes, okay. Then one of the things that people like to confuse lah. Image type we got 2, right or not? We got 2 types of image, right? What kind of image do we have? The nature image. We normally get a real image, and we get a real image, and then we get a virtual image, right? Now, do you know what is the meaning of this real virtual thing, actually? Do you know what's the meaning of this real and virtual? You know, people always say, I don't know, right? Okay, now, here's the thing. Let's listen to this. Real image, right? It means image that can be projected. As in, let's say, you got any lens, any mirror, you point to the wall, there will be image show there one. That's called real image. Virtual, it means you can only see them, but they cannot project out one. Now, example, for projectors. Think about projectors. Let's say, let's say this is a projector. If I point the projector to the wall, what do you see on the wall? If I point the projector to the wall, what do you see on the wall? You're going to see whatever showing, right? You're going to see a face there, yes or no? Right? That's called real image. Virtual means what? You can only see them, but they cannot be projected out. Example, simple as this. Let's say I have a piece of mirror here. Okay, I have a piece of mirror here. Now, if I put my face, here, later, what should I do? Okay, if I put my face here, okay, can you see my face on the mirror? Can you see my face on the mirror? Can I? Okay, now what I do, right? I do the same thing. I put my face here. The face will reflect by the mirror and then to the wall. Okay, do you see a face here when I do this? Do you see my face here? No, right? That means what? It means whatever image form in the mirror, it's a virtual image. You can now, as you can see my face in the mirror, yes, but actually they don't project out. I don't point the mirror to the wall, then suddenly my face show there, right? And by the way, if you have this kind of mirror, please throw it away, you know. Yes, burn it down to ash. How scary is that? Right? Imagine you go toilet, you brushing your teeth, you look into a mirror, there's a face in the mirror, at the same time there's another face at the wall behind you. Wow, that one, we have a problem right? Another example, okay, what I have here, it's a very low power spectacles. Okay, now you see when I wear these spectacles, right? Can you see my eye? Can you see my eye? This is not imaged. This is not object. This is image. Because why? Now this is the real object. But when you go through the lens already, right? Okay, when now whatever you see now is through this lens, yes or no? So this is actually image already. Now again, you can see my eyeball, yes? See, object, go through lens, whatever you see now, it's image, right? You can see my eyeball, yes? But now you see, I put my face in front of the wall. Do you see two eyeballs here? Image that cannot be projected, virtual. Image that can be projected, real. Understand? Okay, we good. Then we can move on. Now back to the questions. Now you want to project the image, project the movie to the wall. What should I use? I need a lens that produces real image, right? What lens? Use the characteristic I told you just now. Can it be concave lens? Concave cannot why? I say already concave lens is diverging. They only generate virtual image. They will never be real. There's only one type of image. There's one type of image that can be one kind of a lens that generates real image. Exactly. The answer is convex lens. Okay, convex lens. Now, state the reason of your choice. Why do we use convex lens? Why do we use convex lens? No, to be honest, magnify is not your main concern. Again, reason of choosing convex lens. Because it produces a real image. I mean, you say converged, not important, right? What most importantly is what? You need the real image so that the image can be projected to the screen, right? Real image, definition, image that can be projected onto a screen. State the characteristics of the image form. In 5.3, what image is this? Virtual, you will not see anything on the screen already. The problem is virtual, you will not see anything on the screen. That's why your object is from here. The object is from here. You want to point at the screen, you see your image. That is real. I mean, that's exactly what I'm showing you, right? Yes. Now, look, convex lens. Look at this, number one, of course. You know that this image is definitely magnified or diminished. Magnified or diminished. Hey, hello, you go to cinema, the image you get, of course, magnified, right? Where got diminished one? Okay, next, magnified. Then, I say already, if you're going to be able to project it, it must be real. And then I also say, right, real. One package with real must be inverted. Correct. Okay, people tell me upright. No, it's not. It's inverted. You say, hey, God, man, I thought whatever I see is the correct orientations. Whatever you see is correct orientations. But who said that this is an upright image? No, it's not. But again, I say already, upright does not mean the orientation is upward. It means same with the object. So you know what they do or not? On the projector here, they terbalik the object one. They purposely terbalik the object so that when you inverted this, it turns out to be like this. So what you saw is still an inverted image. Do you understand the idea? Yes, again, real and inverted, one packaged. Real and inverted, one packaged. They always comes together as a package. Get it? Next one. Aside from applications utilized in 5.3, the lens mentioned is frequently utilized to assist reading. State the application of the lens. Convex lens, we use it for reading. You know what lens, what kind of application is that? Glasses is not accurate. Glasses is not accurate. Magnifying glass. Yes. Convex. Oh, no. Listen, your glasses is concave. Are you having short-sightedness or long-sightedness? If you're having short-sightedness, right, your lens is concave lens. Your lens is concave lens. Long-sightedness is for old people one. Then they wear convex lens. To be very honest, actually long-sightedness, right, they are wearing a magnifying glass. That's right. Okay, you got any grandfather, grandmother, or maybe your father, mother, they wear the long-sightedness glass. Their eye look very cute one, right? Like very big one. Yes, because they are wearing a magnifying glass. So it magnifies the eyeball. But for normal spectacle, Ivan, they make the eye smaller one. Okay. Next, by using the ray diagram below, explain how the image is formed. Explain how the image is formed. I mean, draw in a way, right? And then in the explanation, state the characteristics of the image. Well, here, convex lens, right? First of all, you can draw the shape first. To be honest, they're supposed to draw for you, but we draw ourselves, okay? Now, one we draw here. Okay, we put the shape not important, agak draw only, okay? We don't even need the curve, to be honest, right? We just need the straight line in the middle. Okay, spectacles cannot. Spectacles, we got two types of spectacles, so not recommended. Just mention magnifying glass is better, safer also, okay? So what we have here, it's a convex lens. All right, first of all, what kind of image you want for magnifying glass? For magnifying glass, what kind of image you want? Magnify, yes. Some more? Okay, magnify is one thing. What is the second point? Upright, yes. Must be upright. If not, how are you going to look at how are you going to read? Whatever you see on the screen, tabale. No, right? Whatever you look at the magnifying glass reverse one, then you have to look at it yourself like that. The main concern is you want, okay, here's the thing. Your criteria, I mean, what you wanted from a magnifying glass. Number one, of course, you want a magnified image, right? Second, you need an upright image. And that being said, right, the image must be virtual or real. I say it like third time already. Upright and what? Packaged. Virtual. Real and inverted together. Okay, I teach you a trick. You remember alphabet's letter or not? What comes after U? What comes after U? S, T, U, V. Yes, so U, V together. Understood? Yes. Now, we don't need magnifying glass to be real one. Why? Like you put a magnifying glass in front of your book, your eye can see whatever on the book, right? But do you need that thing project on the wall so that your whole family can see, can read the book together? That's the idea. You only saw them, right? They are not being projected out. That means they are real. Oh, that means they are virtual. Understand? So based on this criteria, where should you put the object? Based on this criteria, where should you put the object? You want magnified means for sure must be before F lah. Before 2F lah. Okay, must be before 2F. Most importantly, now they give you a point F only ma. You have to decide this thing. Where you should put the object. Where should I put it? Then I get a virtual upright. Where should I put it? Yes, before F. Okay, now I know I told you on F also. You will get virtual upright magnified, right? But you know why we don't put on focal point? Because when you put focal point, look first, don't copy this, look first. If you put object and focal point, look at this. If you put exactly on focal point, right, this will happen. What kind of light ray is this? They don't form image one. You understand? So cannot put here. You're supposed to put it before. Now don't put too close to F. Later you regret one. So normally I recommend halfway lah. Okay, close. Like this is the lens ma. This is the focal point ma. You put right in the middle, then enough already one. There's no requirement. Oh, this one we are drawing for magnifying glass, not for projector. That's why we have to put here. Okay, so is that why you tell me it's real? This is the drawing for magnifying glass. Yes. Now, for projector, yes, you want a real image. But then here we are drawing for, because you see up here, they ask you application for the lens, right? Then move on now. Maybe the question never stated properly lah. So what we are drawing here, okay, now I write for you. This one, right? What we are drawing, it's actually the drawing for magnifying glass. Yes, this is actually magnifying glass punya drawing. That's why magnifying punya characteristics, magnified, virtual, upright. This makes more sense now, right? Okay, good. How to draw? Used the two lines I taught. Convex lens, first line how to draw. Convex lens, first line how to draw. Go straight, go to F, good. So always start from the head of the object, go straight, go to F. Second line, go through where? The center. Now, what line is this? Do they look parallel to each other? They are not. So what are we supposed to do? Cannot meet one. So how? Extend, 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 extend. You will get answers right. Now again, whatever line you extended, they must be dotted, 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 dotted all the way. Okay? I mean, don't dotted the whole thing lah. All right, stop at this here. Very good. Then what image do I get? If it's dotted, then the image will be dotted as well. Okay, and now you get a magnified, virtual, and upright image. Are we good? I go toilet. Okay, I'll come back in 3 minutes. But you finish drawing this one. When you're done, right, try the bottom question. Try to do the calculations. Okay, I'll be back real quick. Okay, I'm back. Are you done? Are you done the drawing? Next. Okay, calculations. So what we have here, diagram 11.4 shows an object in front of a convex lens. Always, right, first thing you pay attention to what kind of lens you are given now. Yep, then you identify yourself lah. This is under what? Convex lens, what group? Convex lens, what group? Convex lens is under converging, correct. Now, calculate focal length of the lens. So what do you think? You have to supposed to calculate f, am I right? What kind of formula do you use here? You want to find f, and what's provided here? The distance, right? Yep, the lens formula will be 1 over f, okay, equals to 1 over u plus 1 over v. 1 over u, how much? Now listen to this. Whatever you measure, right, always measure from the center. So your u will be 12 cm, correct? So 1 over 12. No need to convert meter, just leave it there. V, how much? What's the value for v? 36, correct. Why not 48? This is a very typical trick they do in exam. Purposely one. They give you the whole thing. You see number, you copy only what? Then you take 12, you plus 48, then you're gone. Why? Because we start from here. So from the lens to the object, that's called U. From the lens to the image, that only called V. Do you understand what I mean or not? For V. So that's why, right, you have to minus off the 12 here. That's why I only got 36. Understand? So what do you get? 1 over 12 plus 1 over 36, you get 4 over 36. 4 over 36, but then mind you, this is 1 over f, you know. So f is how much? Terbalik. 36 over 4, yes, 9 cm, settle. Next one, calculate the power of the lens. Power of the lens. Power, how to calculate? Formula. Power equals to 1 over f. Power equals to 1 over how many? Okay, what do you put for f? 1 over 9, gone. 0.09. Now, that's why I say must put meter. Yes, you need to convert the cm to meter. Then you get 11.111111, right? That's why typical thing, you lose mark because you careless. Unit for power. Okay, do you know what's the SI unit for power? I mean, yes, you could form yourself lah, right? So a lot of people will tell me it's my m minus 1, correct? But do you know what's the unit we use for power? If you're going to say W is wrong, that one is another power. This is power of the lens. Yes, D, diopter. Okay, have you seen those advertisements about camera before? Advertisement of camera. Like they will say like, this is a Nikon 40D. This is a Nikon 500D, whatever D. The D is basically telling you the power of the lens. Yep. When you get to this point, you're not done yet. This is one of the things that every time people forget. Now, for power, only for power, you are supposed to put symbol here. Okay? You are supposed to put symbol here. Well, how do I know? What symbol do I put? Very simple. Okay? The focal length for convex lens, it's supposed to be positive or negative. Focal length for convex lens. Look up to the rules I said just now. The focal length supposed to be positive, right? If your focal length is positive, your power will be positive. If focal length is negative, your power is negative. Got it? So that's why in front, yes, even it's a positive answer. To be very honest, concave lens, I don't worry because why? Concave lens, right? The focal length itself is negative. So you will automatically put negative yourself. This one turned out negative. That's fine. But then the problem now is what? Because this is positive. Then what happened? You're supposed to put plus. Yes, even for positive, you have to put a plus there. Only for power. The rest, no need one. Only for this. And must put, when you don't put plus minus, it's wrong. A lot of people you try to, you feel like you can get lucky. What if I don't put? Maybe teacher give marks because I'm not sure whether plus or minus. You don't put, you're wrong for sure. Okay, so in front of power, must have plus or minus. Convex, positive for power. Concave lens, negative for power. Understand? Now next one, number 3. How do we calculate magnifications? I say already many times, magnifications, right? The idea is what? You don't care about plus minus, just the number. And in this case, what kind of formulas do we use? Because remember, right, magnification, actually, you got two formulas. You can do V over U, you can do height over height. And in this case, obviously, what you do? Yes, you got no height also, right or not? So V over U. But the idea is do this, right? To have image divided by object. So the image, it's actually 36. The object is 12. What kind of answer we get? 3. You know what means by this magnification equals to 3? Your image is 3 times the size of object. Your image is 3 times the size of object. If I get magnification 0.5 means what? The image is 0.5 times of the object. Understand? Okay, I'll teach you one more trick. Now, sometimes, right, when you're doing calculation, there will be another question add on there on. They will ask you like, describe the characteristics. Well, beside using the shortcut I mentioned to you just now, I give you another thing. Through these numbers, you can also tell whether your image, is it real or is it virtual? Okay, whether your image, is it like inverted or upright? Now, first thing, right, you know how you tell the size? You know how you tell the size? Whether is it magnified, diminished, virtual? Look at this will do. Okay, you compare, okay, first of all, if you want to know the size, right, very simple one. You compare the value for V and U. You compare the value for V and U. Now, you compare these two. Which one is bigger? V, it's greater than U, right? V is greater than U, right? That is one answer. You can tell the image is magnified. Okay? That means now, if every time you compare, if your V it's more than U, that's magnified. If your V it's less than U, diminished. If V it's equals to U, same size. Okay. Second, how do you know whether is it real or virtual? Very simple. You look at V also. Okay. Now the value for V here, is it a positive or negative 36? Yes. So that's why, right? This one you get real image. Why? Because V it's positive value. Okay, and finally, I say 1,000 times already, right? Real must be a package with inverted, correct. There you go. So no drawing needed. Look at numbers, can tell characteristics as well. We good? Can I move on? Next one. Next one. Okay. Next one. Lenses are often used to correct defects such as myopia and hypermetropia. Okay, do you know what is the meaning of this word? Myopia, hypermetropia? They do this one. Why? If they tell you short sightness, long sightness, very easy, ma. They give you words that you don't understand. Myopia means short sightedness. Hypermetropia means long sightedness. I teach you a trick. You look at the name, the word is shorter, short sightedness. The word is longer, long sightedness. Simple? Okay, good. Now, first of all, we say short sightedness. You know what's the problem for people with short sightedness? Actually, you know why is it called short sightedness or not? Because the image formed too fast. Look at this. By right, if you want to see clearly, where you need the light to focus. If you want the to be able to see clearly, where you want the light to form, you must focus it to the where got form on a lens. Hello, lens is this. They help you to collect light. You need the light to form on your retina. Yes, you know where's the retina or not? The back of your eyeball here. Okay. That's why, you know, there's one thing that, and I'll tell you one thing, okay. A lot of times when you look at movie, you know they are not real, and then you know they are a bit dumb. Always got this kind of movie that shows like human with superpower. Is it good that you can become transparent? Is it good that you can become transparent? Like, you know, I can, you know, go inside the bank, I take the money. No, it's not. You know why? When you are transparent, you will go blind. What means by transparent? Light go through, yes. Then how are you able to see? The light don't form on retina anymore. They go through you. Suddenly you realize, right, being transparent is not a good answer. The moment you're transparent, you're gone. Eyeball not transparent, everybody knows you are right. Hey, two eyeball floating there. Hello. So transparent is no good. Okay, now back to this. That's why I don't like to watch movie. Every time I watch movie, I judge them a lot. Okay, back to this. All right. So problem about short-sightedness. Form too fast. Problem about long-sightedness. You know what happened for long-sightedness, right? I always say, like, old people got long-sightedness. Okay, here's the thing. Long-sightedness, right, actually got two situations. Some people, right, they born with these conditions where their eyeball, right, are more flat. Like normally our eyeball is like a kind of like a round eyeball thing, right? Their eyeball, it's a bit flat like this one. So their lens work perfectly, but because of their eyeball slightly flat, right, the light kind of projected behind. Yes. So when your light ray form too late, then it's long-sightedness because form too long away. This one form too short. That is called short-sightedness. This is called long-sightedness. How do you solve this problem? Using diagram above. Okay, using diagram above, draw the lens needed and complete the ray diagrams. Okay. Short-sightedness people, what kind of lens do you wear? Short-sightedness people, what kind of lens do you wear? You take your lens, you touch a bit and see, wait, does it curve in or curve out? Does it curve in or curve out? Curves in one. Okay, and you know why you need a concave? Okay, what's the problem now? What's the problem now? Your light form too fast. You want a lens to help you to delay the forming one. How do I delay the forming? I put a concave. You know why concave or not? Okay, what does a concave lens do? You tell me what does a concave lens do? Converge or diverged? Converge or diverged? Concave lens? Converge or diverged? Concave lens is diverged one. So what happened? Okay, so now the new light, red color, they come to the lens. What will happen to the light rays? When they diverge means what? Diverge means the light ray will separate. You see or not? Now compare the red one and the black color one. So now your light ray is further away, right? So if they're further away, that means your light ray need more time to focus, right? More time to converge, right? Then they will form behind and they form exactly on your retina. So now your red color light is basically the corrected eyesight. That is what happened for people with short-sightedness. Understand? We good? Now next, what about people with long-sightedness? What's wrong now? What's the problem for their eyeball? Their eyeball, right? Normally, you know why I say old people or not? Because when you get older, your muscle tend to be loose. So they don't converge like so much as we do. So what happened now? We put another convex lens. You know why? I mean, not so crazy okay? We put another convex lens. Your eyeball cannot focus Then we do something to help you focus We put another convex here. So now what happened? You see, from here, view, over. Okay, from here, view, over. From here, view, over. They go through the first lens, they will converge the first time. See, they will focus the first time. Then when they go to your eyeball, they focus the second time. And now they will go to your retina. See that? First time they go through your spectacles, then they go through your eyeball, and now the light will form perfectly on the retina. So this is exactly what happened. Okay? Any questions? We good? Can I move on a bit more? Okay, next. Have you thought of what happened if I got both? What happened if I got both? Both? That means they cancel off, right? You see, this one form too late, this one form too fast. Form be in front of the eyeball, from behind the eyeball, combine, form exactly on the eyeball. I get perfect eyesight again. Where got such thing one? Hello? Yes, let me tell you what. People always say, hey, if I got short sightedness, right, then does it mean I'm immune to long sightedness already? I'm not gonna have this. No, when you get older, you're gonna get both. Yes, you are going to have this and this. That means what? Whatever you see, also blur one. And okay, let me tell you one thing. Did you realize, right? The light ray from the starting point coming to your eyeball is different. Kind of different, right? You see, this one is two parallel lights, where this one you start from one particular point and then opens up right now. Okay, let me tell you what does it mean. Whenever in chapter light, whenever you see light rays, it's parallel to each other, like this. Okay, when do we draw two light rays parallel, or maybe three light rays parallel to each other? We draw this when the object is coming from very far away. Okay, so this one right now, the parallel rays actually got meaning one. Okay, the parallel here. Okay, you make a remark there. The parallel rays here, perhaps this the two parallel rays here actually means distant object coming from very far away. And you think about it, people with short-sightedness, you cannot see far object or near object. Nearer, you got no problem. This thing will only happen when you look at far object. You get it? Now, then do you notice this one, right? They come from one tiny spot and then they opens up. And what does it mean by this? Now, actually this, okay, this one particular point, they open up one. That means this is an object that is very near. Okay, near object, distance object. Can you tell the difference? So when you got both means what? When you look at far things, this will happen. Cannot see. When you look at near things, this will happen. Cannot see. So they don't clash, and definitely they don't cancel off. So don't hope that, oh, I get a perfect eyesight after this. No, you don't. Get it? Yes. Now, you know what happened for long-sightedness people, right? You think about your grandfather, your grandmother with long-sightedness. Every time they read book, they look at their phone, they read newspaper, they bring them very far away, right? Seen that before? Like, let's say this is a newspaper whatsoever. You will see them doing this, right? I mean, for you, you will do this, right? Because they cannot see far. They cannot. They cannot see nearer object. Get it? And how do we solve this problem? Both cannot see, or then how? Change another eyeball. Okay, have you seen like some uncles or aunties, right? They carry two spectacles with them. They wear one, they have another one. Every time they read, they swap. You probably feel like, hey, why this uncle like so forgetful one? Got wearing a spectacle, still carry a spectacles here. It's actually two different spectacles, but of course, you know, when you carry two spectacles, it's inconvenient, and then people tend to think that you have Alzheimer, you forget things. Now, actually, we got lens that combine one. Yes, that can solve both the problem. Now, by the way, when you get two of these problem together, hypermetropia and myopia combined together, I tell you the name to be honest, this is not bio, okay? They don't ask for the name one, but they will put the name there and then you're stuck. If ever you see pressed myopia, okay, this means the combination of both conditions. Okay, the combination of both conditions. Yes. How do we solve this problem? We have to put both. How do you put both? Half, correct. How to half? How to half? How to half? Okay, you got two choice. Do you half concave, half convex like this? Or do you half convex, half concave like this? First combination or second combinations? Cannot anything can one. The arrangement got reason one. Choose one. Okay, I promise you one of them is correct. Answer is 1. You will do concave on top, convex at the bottom. Okay, I mean, to be honest, a lot of people will ask one. Actually, my spectacles, right, they don't curve in both sides. They only curve in one side, right? To be honest, the normal spectacles don't curve both sides. You need one side curve already, enough. So usually, right, the real spectacle is like this. Of course, but what I want you to understand is like this, concave and then convex, right? So this is actually the answer. You're supposed to put convex on top. Sorry, convex block, concave on top, and then convex at the bottom. You know why? Okay, a simple questions. When do you need a concave lens? When you look at distant object, right? Now, look far away in your room whatsoever. Look away. Look at the object that's very far away. Where is your location of your eyeball? Your eye look where? Up or down? Up, right? That means you'll be using here. Make sense? Okay. When you're reading a book, now you look at your book, look at your notes, look at your iPad, whatever. What happened to your eye? You will start looking downwards, right? That's when you will use the convex. Get it? That's the trick. Okay, so presbyopia, you solve using this method. Okay. All right, any questions? But to be honest, this one not exactly in your syllabus. They could ask, but this is more important. Can we go on some more? Can we go on some more? All right. K-bar could be, right? Of course, this is kind of K-bar lah. How laser works on eyes, the one is they cut off your cornea. Not to cut off lah, they shape it. That's why you know, people who go for laser, like let's say you got very serious short-sightedness, then people go for LASIK. What they're doing is that they're using the laser to cut a bit off your cornea. That's why before you do, they have to check on. If your cornea it's too thin, then you cannot do. So because cornea actually quite thick on, you can actually cut off a bit on, like you know, you peel off a bit the skin like that. So you cut it off to kind of reshape it back to the perfect shape. Does it hurt? I never done before. I don't know. But I suppose everything with a surgery hurts one. You're not gonna feel it lah, because you'll be probably in under anesthetic. But a long recovery. Is it good? It will depend. To be honest lah, if you do it just for the sake of looking nice, you say, oh, I want to look pretty, I don't want to wear spectacles. Not worth the risk. You know, even people, if even a person who invented LASIK, don't recommend people do LASIK unless you need it. Now, if you're having like a crazy serious short-sightedness, you are like 1000 degree one, you literally go blind without spectacles one. That people recommend you do it. So that one is more for medical needs. But a lot of people nowadays, they do it for looking nice, because wearing spectacles very troublesome, don't look pretty, that kind of thing. But to be honest, is it permanent? That will depend on how you take care of your eyeball. It comes back one. It will come back one. Oh, astig is not in syllabus. Astig is very, very different. It's the astigmatism is another different story. That one, we don't wear convex nor concave lens. Okay, now back to this. Diagram 5.1 shows a slide projector used to display a large, sharp image on the screen. Have you seen this kind of projector before? The very old style projector, we don't use this anymore. Like, but when you watch movie, you usually got one. A very old style movie, they want to show stuff, and then it makes sound like kikak like that. They will swap the projector. And then usually this will be like your typical horror movies. They found a stack of slides on top of their roof, and then they started to start playing them. Then they go like normal photos of family portrait, then start going crazy. All the family start dying. That kind of you know, typical horror movie. Yes, slide projectors. We don't do this anymore lah. We use the digital now already. Okay, so same thing, based on diagram 5.1, determine the focal length of the lens. Well, I think you know what to do, all right? Formulas, we can go faster for this, right? Focal length 1 over f, okay, equals to 1 over u plus 1 over v, right? 1 over u is how much? 1 over 25. 1 over V is how much? 1 over 70. Now, these are quite easy because why? Everything measured properly for you already. Okay, just have to calculate answer for me. 1 over 25 plus 1 over 70. What do we get? In terms of fractions, 1 over 70, 1 over 25. Did you get 19 over 350? And then F is how much? Terbalik. Yep, 18.42 cm. Okay. When do we use negative value? Now, U already say there's no negative for U. V, you put negative if the image is virtual. So you think about this, is this the virtual image or real image? It's a projector. Projector projects image, must be real. Yes. If they say negative, if they say virtual, then you put negative. Diagram 5.1, calculate the power of the lens. How do you calculate power of the lens? Formula 1 over focal length. Can we 1 over 18? What's the answer? 1 over 0.1842. 5.43 diopter positive. Do you get this? We good so far? Next one. The slide used has an area of 5 cm square. Calculate the area of image form. How? Yes. Okay. Of course, the image will be bigger or smaller. Bigger. By how much? Would you know? Then what are you supposed to do? Yes. What do you calculate first? If you want to know the image will be magnified by how much? Yes. You're supposed to find magnification first. How do we find magnifications? V over U. All right. V, it's how much? 70. U is how much? 25. 70 over 25. How much do we get? 2.8. What does it mean by this 2.8? It means your image will be 2.8 times larger than the object. Get it? So what is the area of your image? We take 5, multiply by. That is how they get you again. Did you do this? I said what? Just now. If you're going to calculate magnifications, you can only use it to calculate the height or the distance. And this is a area. So what are you supposed to do? Square the magnifications. This is maths actually. Do you remember you learned something called enlargement? Maths, scale drawings. You got the magnifying factor, K. If it's area, you K square. Same. And by the way, look, this thing, is a square slide. So your object will be like this. A square that the area is 5, right? You know what it means by square, right? You know what's the meaning of square, right? It means they will have the same length for each side. Well, to be honest, can you find out the height first? You could. Since it's a square, what do? Literally, you just have to square root both sides, right? You square root 5 is the length for both sides. So what you can do also, you could actually just get height, okay, of the image first. How? You take square root 5 and then multiply 2.8. So what you get is the height of image. Then after that, the area of the image, what you do? You literally take this one, okay, this whole thing, the height, multiply both sides, because height and when you are square, right, this side, same one. So this whole thing square, what happened? Cancel off. The square went inside. That is why I will do this. Understand? I mean, if you understand logic, you don't bother showing this at all. You can just straight away do this. But of course, if you're wondering why we square the 2.8, it's because, right, this is area. You cannot take the area multiply straight away. Yes, you have to find out the height first. No worries, they will give you, you'll start asking, hey, what if this is not a square? Then they need to tell you both sides. Then cannot. So that's why normally what we do, we just take the area, we square the magnifications. We good? Can I? All clear now? So this is another question that quite interesting to be honest. Okay, a bit of hot, a bit of tricky part where people lose mark. So be extra careful when they don't mention height or length. If they say area, then you need to square your magnifications. Okay? Come, we finish up the essay question as well. Since we talk about projectors, so might as well we discuss this, right? Can I move on? Can I move on? Okay, good. All right, here. Diagram 11.2 shows a colored glass picture of a butterfly. Student intend to project the colored glass picture onto a large screen. So you have a choice of 4 different projectors. What you want is that you want to display a bright, okay, large, upright image of a colored glass, right? So first of all, you look at this. What are the idea you have? You need to have now. First of all, what happened? The cooling fan first, easiest one. Which one do we choose for cooling fan? Do you notice the difference between cooling fan? It's big or small, right? You know why you need a cooling fan or not? We are using a very strong light bulbs, so they are going to be very hot. So what do you need for the cooling fan? Big or small fan? Big or small fan? Of course, the big one. So we choose big one. Okay. Now next, the lamp supposed to be 400 watt or 800 watt. The lamp. Okay. Watt means joules per second. Remember, we mentioned this, right? So 800 watt. Yes, that means higher power. You know why you need higher power? Because the higher the power, the brighter the bulb. The brighter the bulb means the brighter the image will form. Next one. Did you notice that this one, they put U 4 cm, 8 cm? Okay, should you do 4 cm or 8 cm? Okay, by the way, I'll give you a hint. They tell you the projector length is 5 cm focal length. The projector is 5 cm focal length. Okay, first of all, again, whatever projector it is, do you need a real image or do you need a virtual image? You need to project it. You want to project it. You need a real image. And in order to have real image, where should you put object? Now you notice why I spend so many time discussing, explaining this to you, right? Because they keep using it, not just only drawing, not just only typical questions. Now, this thing makes sense now? Where you want to have a real image, you must put it what? More than F. More than F. Understood? Yes, you want a real image, you must put more than F. Now, what does it mean by more than F? F is 5 cm. Your U is supposed to be what? Yes, it should be 8 cm. Should be 8 cm. Okay? And finally, the colored glass picture supposed to be upright or inverted. I told you the working concept for projector already, ma. Now, okay, here's the thing. People misunderstood this meaning. They say, hey, but they want upright wall, right? Now, actually, what they mean by this upright, it means that they want something like this. When you saw the image, it's the correct orientations. The upright meaning here is that they want the image form, it's the correct orientations. I know it's a bit confusing here. To be honest, they're not supposed to use the word upright. They should use the word upright. I'm sorry, upward. Okay, the correct orientations. So how do I get these correct orientations? I say already, right? Projector concept. Now, listen, projector, you surely need real one. There's no way you don't do real for one simple reason, because you need to project it. Project, sure real. And project by nature, sure terbalik one the image. So how do I make sure they come out, look like what we wanted? Before that, how you put object? Yes, you purposely terbalik your object so that the image will turns out to be the correct orientations. And which one fits all the criteria? Exactly, configuration X. Understand? So bigger fan, cool down faster, cool down more, brighter bulb, brighter image, clearer image, inverted object, we get a correct orientation, we get an upright image. I mean, again, the word upright here does not mean like same directions. I get it. The word kind of misleading you. And then the U must be more than F. Why? U more than F, only you get real image. Understand? So you see, the lens idea, when you understand the one page I said just now, it will help you to answer your questions one. Now, same would have applied to every subtopic. To be honest, I prepare so many chapters for you for what? I'm not going to discuss every one of them, right? It's mainly that, those are the topics that in exam come out, you sure die one. So notice that when I put in all these details, please go through them. Okay, I show you as simple as this. With that one page of lens concept I gave you, right? We can use this to answer your lens questions. See that? So go through your interference questions. Go through those gravitational questions. But up to now, any question regarding this? Very good. Very good. Okay, one more thing. I know everybody is concerned about one thing. The microscope how? The telescope how? Right? Now, in the notes, I prepare you the drawings, the configurations already. I know some of you when you look at the book, you say, hey, I cannot understand the drawings, right? Okay, let me tell you a few things. First of all, whatever we do today is recorded. I will post it in YouTube, right? So what you simply need to do is look for this YouTube channel. Okay, I'm sorry, I need to advertise a bit. Not advertise. Basically, it's telling you where to find this thing. All right, the answer. Now, if you are my own students, right, I will post in Google Classroom one. Then if you are not my students, it's fine. After that, probably by Friday I will post the answer in the Google Drive. Where you get the PDF file, it will be there also. Okay, but for my own students, you can find it in your Google Classroom anyway. Okay, now one more thing, the drawing for telescope and microscope, it's inside here. And also, you go through the channel, you probably find a few videos that you might be interested. It might help you for different chapters. Okay, so other chapters, find it here. Okay, is there any questions you'd like to ask? If not, I hope you learned something today. I hope that, lens is no longer so scary to you. Okay? And I think that's all for today, right? If questions, you can ask. If not, I will see you when I see you. Bye-bye.